So oscillators
Yes,
are
ma'am.
the circuit that generates a repetitive waveform of fixed amplitude and frequency without any external input signal. What is the principle here? That it has a feedback amplifier in which the part of output is fed back to the input via feedback circuit, and the signal which is produced at the output is nothing but the of alternating current or voltage, right? So from this we have seen the formula that part of output is fed back to input. You can see here. So we have written the formula and we got V naught upon V in as AV upon 1 minus AV beta. What is AV? AV is the amplifier gain and beta is the feedback network gain. So in this we can say that V naught is not 0 but V in is 0 because without input output has to be generated. So without input means V in is 0 but V naught is not 0. When V in is 0 and V naught is not 0, that means only that is possible when 1 minus AV beta is 0. So 1 minus AV beta को 0 किया हमने, तो from that we are getting the gain is 1 minus AV beta equals to 1. That is AV beta equals to 1. 1 minus AV beta equals to 0. That means 1 minus AV beta equals to 0 or AV beta equals to 1 angle 0. That means the magnitude of loop gain AV beta must be at least 1 for the oscillator. And the total phase shift of AV beta should be 0 degree or 360 degree. That we came to conclusion when we started with oscillators. Okay. Now these two conditions are nothing but called as Borkhausen criteria for oscillation. What are the two conditions? The first is AV beta should be 1 and the phase should be 0 degree or 360 degree. Why 360 degree? Because we know that when you cross, we come back to 360, it is equivalent to 0 degree. So we are writing it as 0 or 360 degree or 720 because it repeats anyway. So it is 0 or 360 degree. This is called as Borkhausen condition criteria for the oscillations. Now next is, I have shown you here an amplifier because we have to see the oscillators in terms of op-amp. So amplifier, in place of amplifier we have an inverting amplifier. We have an inverting amplifier and feedback circuit. I have just connected a network with beta. Now you can see here what is AV. AV is nothing but minus RF upon R1, right? So when the gain is already, just mute yourself. Someone is unmuted. Just check who is unmuted and please mute yourself. Yeah, so the gain is already here. You can see minus RF upon R1. And what do you mean by minus here? That is minus is nothing but the phase is 180 degree because cos 180 is minus 1. So phase is already 180 and according to the Borkhausen condition, we should have a phase of 360 degree. So we should have extra 180 degree in the feedback circuit. So if you are using an inverting amplifier as an amplifier AV, so AV is already having a negative gain that is 180 degree phase and extra 180 degree you need for an oscillator and that 180 degree you have to produce by a feedback network. So we are going to study two type of oscillators, RC and LC. Sorry, there are three type of oscillators, RC, LC and crystal, but from that we are going to only study RC oscillator which are used for audio frequencies. While LC and crystal oscillators are used for high frequencies. And RC oscillators also we are going to study two type of RC oscillators. One is RC phase shift oscillator and one is Wien bridge. From that we started with RC phase shift oscillator. As I told you, any complex number a plus jb can be written as root of a square plus b square and angle tan inverse of b by a. So if you see a plus jb ki jagah we have an RC. If I have a RC phase shift, when I am saying we have RC component, I can get r plus 1 upon j omega c. So I can get this type of magnitude and phase. So depending on, we want 180 degree phase shift, right? So depending on this, if I say that एक RC component, single RC component का phase जितना होगा, we have to have the RC components in cascade to have a 180 degree phase shift. So there are two types of RC components we can have. One is we can have a 45 degree phase. 90 degree phase होगा तो हमारा एक component 0 हो जाएगा, that is R. But that we cannot have. We have a RC phase shift oscillator. So we can have a phase shift of either 60. When we have a phase shift of one single RC component is 60, we can cascade it in 3 and get 3 RC circuits to have a phase shift of 180 degree. And when we are using a 45-degree phase shift, we'll have a 4 RC components. But already the commercially available is a 3 RC phase shift oscillator. So you can see this circuit diagram I've already shown here that 3 RC का हमने network लगाया हुआ है in the feedback and 180 degrees through amplifier and 180 degrees through the feedback network. So this is an oscillator and you are going to do a practical also in this. You are not going to give any input and depending on the frequency of this RC component, you will get the output signal. Okay, so I told you that for this AB beta equals to 1, we are going to take the condition as AB beta equals to 1. And if we find with this condition what is F naught, so F naught you are going to get is 1 by, just a second, yeah. Yes, sorry. Yeah. So if you find this, if you use this condition AB beta equals to 1, if I'm going to do the derivation now. So if I use this condition for this circuit, you're going to get F naught equals to 1 by 2 pi root of 6 RC. And AB will you're going to get is 29. Okay, so this is the derivation we are going to do for RC shift, जहाँ पे हमको F naught और ABA मिलने वाला है. Now, how will you design? What are the design steps? The design steps will be F naught will be given to us. What is F naught? The frequency which you are going to have in this RC phase shift oscillator. So F naught is the frequency. Using that frequency, we'll assume the value of C and we'll get the value of R. Because of the formula, we have F naught is 1 by 2 pi root of 6 RC. And we can assume then RF by R1 is gain AV 29. We can assume the value of R1 and then we can get the value of RF. So this is the value of R1 we'll get. So this is your F naught and this is your two formulas are there, F naught and RF and R. If that is clear, we can go with the derivation and then some problems on this. Is it clear about RC phase shift oscillator?
Yes, ma'am.
So I am starting with the derivation of RC phase shift now. Okay. Any doubts on this? You can ask me. Okay. And derivation is important here for RC phase shift. It can be asked in exam. So just see what derivation we are going to use. That how we got F naught as 1 by 2 pi 6, 2 pi root 6 RC by. So let me start with that. Again, we'll draw the circuit of RC. So we have an op-amp. I think now you know when I say RC, you can draw the diagram at least. This is your R1. Is my screen visible?
Yes, ma'am.
So just you note the derivation along with me. It will be easier for you to understand that. So this is your RF and R1. This is your gain is minus RF by R1 we know. And this is R. And then you have a feedback network with RC components. I'm drawing again for you. And you also draw with me so that when RC phase shift, any problem is asked or the derivation is asked, the diagram is clear to you. So this is your feedback and this. the derivation, when I say, I'm again telling, any derivation is nothing but KCL or KVLs. Mainly you see KCL we are going to write. KVLs तो हम अभी लिख ही नहीं रहे, all KCLs. So you are going to apply KCL. Any op-amp. Now exams are also there in UT2. I'm telling, just I'm giving you a hint. The problems, यही problem आ गया मान लो, and it is asked to find VO by VE. So don't consider it is the problem of op-amp or LIC. VO by VE पूछा तो you know KCL लगाना है मुझे, and you have to get the VO by VO. Here the frequency of AV beta. यहाँ पे V in तो है ही नहीं. So when I say this type of circuit, you have to find AV beta, suppose. So you read what is beta, you know. So we have to find the beta. What is the beta here? So this is a diagram now, and I'm going to start with, yes, AV beta. When we say, yes, this is V2. What is beta here? Tell me. This is V2 and this is V1. Yes? And this is V0, right? Yes, can we write the equation? And what is beta here? What is this signal which is there? We'll call it as VB, because this is only coming to the input, right? Can we start? How many KCLs we have to write? Yes, hello. Am I audible? And my screen is visible?
Yes, ma'am.
Yes. So tell me now, I have, this is your, I know my Brock-Hessen condition is what? What is my Brock-Hessen criteria for oscillations that I have to start with? What is that condition? AV beta equals to 1. Yeah. Tell me what is AV? Yes, tell me what is AV? Any one of you in this network? Yes, what is AV? Any one of you?
Minus RF upon RI.
R1s. Yeah. Minus RF upon R1. Yes, very good. This is AV. What is beta? What is beta? Can anyone tell me what is beta here? Because we have to use this condition. What is beta? Beta is, can anyone tell me what is beta? I have given you all the names. Which voltage divided by which voltage? VB by V0, right? Because beta is the feedback network ka gain. What is that? VB is the output of feedback network and V0 is the input. So VB by V0 is your beta. Now we have to find that beta, and then you have to multiply by AV, and that we have to equate it to 1. Now to get that value, we have to write 3 KCLs because V1 or V2 beech mein hai. That is unwanted. So we'll write now KCLs. See, all of you look here, I'll do fast because these are only KCLs, and I'll just write, you know how to write KCLs. So I'm writing now the KCLs here. Yes, what will be the first KCL? I'll start from the backward, that is from V2. Okay, just look at here, I'm writing down V2 by R plus V2 minus V0 upon 1 by SC plus V2 minus V1 upon 1 by SC. If any doubt, you can ask me. I'm just writing continuously. This is your equation number 1. But before writing equation number, I'll just simplify this. I'll write down V2 सब एक साथ ले लो, R plus 2SC. V2 एक साथ ले लिया, equals to V0 SC plus V1 SC. R नहीं, sorry, I've done some gadbad. This is 1 by R. Right? If I simplify this more, it will be V2 2SCR plus 1 upon R equals to V0 SC plus V1 SC. Equation number 3. 1 और 2 तो हमने नाम दिया है. Is it clear? Is this equation clear? कहाँ पे लगाया हमने? I am starting from the last node at V2, KCL at V2 we have started. The first equation I have written V2 by R plus V2 minus V0 upon 1 by SC plus V2 minus V1 upon 1 by SC. I got this equation. Is that clear? Can I go to the next node?
Yes, ma'am.
Yeah. I will not now write KCL at V1. Right? KCL at V1. KCL at V1. Now when I write KCL at V1, what will be the equation? It will be V1 minus V2 upon 1 by SC, right? It will be V1 you have the diagram with you, so I'm not just zoom it and write. Yeah. What is the second equation V1? It will be V1 minus V2. Just see your diagram. V1 minus V2. V1 minus V2 into SC. 1 upon 1 by SC is nothing but SC plus V1 by R plus V1 minus VB into SC. If any doubt, you can ask me. See, 1 upon SC है नीचे, V1 minus VB upon 1 by SC मैंने उसको ऊपर ले लिया. So if I simplify this, it is V1 2SC plus 1 by R equals to V2SC plus VBSC. If I simplify more, it is 2SCR plus 1 upon R equals to V2SC plus VBSC. This is equation number 4. Now the last equation, KCL at VB. 3 KCLs I have to write. KCL at VB. When I write KCL at VB, my equation will be VB upon R plus VB minus V1 into SC equals to 0. Right? VB by R. Yes, what will be that? If I simplify it, it will be VB 1 by R plus SC equals to V1 SC. So VB 1 plus SCR upon R equals to V1 SC. This is equation number 5. Now look at 3, 4 and 5. हमको चाहिए क्या? VB by V0. What are unwanted here? Unwanted is V1 and V2. Unwanted is V1 and V2. So from 5 only, this only, I'll write that. What is my V1? V1 को हम हटाएंगे. So V1 equals to VB 1 plus SCR upon SCR. This is my V1. This I'll name it as 6 suppose. इसी से हमने V1 लिख दिया. V1 I have to remove from 4, 5. 3 and 4. 5 तो हमने यूज कर लिया. 3 और 4 से हमको V1 हटाना है. V2 भी हटाना है. We want VB upon V0, right? So put the value of V1. Put the value of V1 into 4th equation. So substitute V1 into 4. So when you understand that we want VB upon V0, we'll substitute V1 from above in equation number 4. Now, if I put the values of V1 in equation number 4, what was my equation number 4? It was V1 वहाँ पे रख देंगे, तो V1 will be equation number 4 देखो तुम लोग already तुम्हारे notebook पे. So I'm writing in place of V1 as VB 1 plus SCR upon SCR into already we have 2 SCR plus 1 upon R there. तो यहाँ पे V1 की जगह VB डाल दिया equals to we have V2 SC plus VB SC. So when I substitute V1 from above in 4, I get this. I'll simplify this. What I'm getting VB अभी भी V2 pending है, हाँ V2 हटाना है अभी. So VB, if I multiply this, what I'm getting is 2S square R square C square plus 3 SCR. If I multiply, I get this right. Plus 1 upon SCR square. VB right hand side में भी है, उसको इधर ले लो. Minus SC equals to V2 SC. So if I simplify, finally I am getting is 2S square R square C square plus 3 SCR plus 1 minus S square C square R square upon SCR to V2 SC. So VB, if you see that 1 S square C square R square minus this with S square R square C square plus 3 SCR plus 1 upon SC R square equals to V2 SC. Now V2 is unwanted. हम 3 इक्वेशन को टच नहीं किए. From this you get the value of V2. What is V2? V2 is VB S square R square C square plus 3 SCR plus 1 upon S square C square R square. This is V2. This you name it as 7. Now this 7 we have to put in 3 because हमारा V2 unwanted है अभी and 3 is pending, right? अभी V2 हमको V2 और V1, that is your equation number 6 and 7 we have to put in 3. Substitute, because initially we understood कि V1 और V2 unwanted है, तो substitute V1 and V2 from 6 and 7 in equation number 3. Okay, so equation number 3 you have, that is V2 की जगह पे हम ये रख देंगे VB square R square C square plus 3 SCR plus 1, ये हम रख रहे हैं V2 की जगह पे, और उसके साथ ऑलरेडी एक्स्ट्रा है 2 SCR plus 1 upon R equals to V naught SC, और V1 की जगह पे भी रखना है V1 का वैल्यू. What is V1 value? V1 value is VB SCR plus 1 upon SCR into SC. वहाँ पे into SC है already. Just I am putting the value of V1 and V2 from 6 and 7 in 3. Now you have to simplify. You see now V naught VB मिल गया हमको, right hand side और left hand side में सिर्फ V naught और VB दिख रहा है. You have to just simplify. Now this is your maths का problem. You have to just simplify and get V naught by VB. Now if you see, and if you do carefully, there will be no mistakes. So VB, now I have to just multiply and get the value of V naught by VB. So I'm just, all of you look here, I'm just multiplying. Yes, all of you look properly. What I'm doing here is I have to just multiply. So it is S cube 2 S cube R cube C cube plus पहला वाला multiply हो गया. Now you have to multiply this with this S square R square C square. The first one I multiplied with this 2, so I'm getting this plus 3 2 is 6 S square C square R square plus 3 SCR plus 2 SCR. You know now how to multiply. I don't need to tell you that. One element you multiplied by all and you have S square C square R square into R equals to side में minus SCR plus 1 SC cancel कर दो यहाँ से, this is cancelled, you have SCR plus 1, this whole is multiplied by VB क्योंकि VB वो साइड में भी है, उसको ये साइड लेके आ गए, equals to V naught SC. Okay, this I have done. Now we have to simplify it more. You see what I am getting. So VB 2 S cube R cube C cube plus yes, ये पूरा टर्म देखो और नीचे जो आ रहा है, नीचे एलसीएम ले लेंगे अगर हम, तो इट इज S स्क्वायर C स्क्वायर R स्क्वायर. आई थिंक कुछ गड़बड़, हाँ राइट, R is also there. This is LCM. So when you take this LCM, this minus term के साथ क्या आ जाएगा एक्स्ट्रा, when you have to multiply, ये सम तो ऊपर रहेगा ही, S square R square C square plus 6 S square C square R square plus 3 SCR plus 5 SCR plus 1 and will be minus R cube C and S square C square R square, right? Now इसमें से क्या क्या कैंसिल हो रहा है? You see one this gets cancelled already. Yes, what else? What else? Tell me. क्या बच रहा है अभी? This is 2. Yeah, and this one will cancel. You have final as VB 2 minus 1 is S cube R cube C cube plus 6 S square C square R square plus 5 SCR plus 1. Okay, and in denominator you have s square c square r square into r equals to v naught sc. Now we got the final v naught by vb. You can write down v naught, vb by v naught, vb by v naught. So if you see, I am getting here is s cube c cube r cube. You take it this in the right hand side, cube r cube c cube plus 6 s square r square c square plus 5 scr plus this is your beta. हमको बीटा मिल गया. This I am naming it as 8. Equation number 8. Beta we got. A भी हमको ऊपर मिल चुका है. Can we start the can we write the condition? What is the condition? I have to put the condition as AV beta equals to 1. Am I audible? There is a pin drop silence. No doubts. Am I audible?
Yes, ma'am.
Yes.
Yes, ma'am.
Yes, ma'am.
Yeah, AV is minus RF upon R1. We have already seen. And beta is this. So I'm writing down that S cube C cube R cube upon S cube R cube C cube plus 6 S square R square C square plus 5 SCR plus 1 equals to 1. Now यहाँ से हमको frequency निकालनी है, right? Now when you are getting this condition, take left hand side as minus RF upon R1. अभी हमको frequency मैच करनी है, तो minus RF upon R1 S cube C cube R cube and denominator को वो साइड लिख के जाओ. What is that? S cube R cube C cube plus 6 S square R square C square plus 5 SCR. How to compare these two? So whenever you get like this, you know what is S? S is nothing but j omega. All of you know this? S is nothing but j omega. So in this equation, I'll name this as 9. In this equation 9, if I put the value of in 9, if you substitute S as j omega, because we want the frequency. If I put S as j omega, what I'm going to get? Minus RF upon R1 j omega cube R cube C cube. Okay, I'm getting in the left hand side. Right hand side also I'll put j omega cube R cube C cube plus 6 j omega square j omega SCR plus 1. Why SCR nahi RC? Now why I'm putting this? Because when I put j omega, I'm going to get real terms and imaginary terms. In the left hand side, what is j square? All of you know what is j square? Is j square minus 1?
Yes, ma'am.
J square
Yes,
is
ma'am.
minus 1, so I'm getting here minus minus plus, and only one j term will be there, j omega cube R cube C cube, right? यहाँ पे j cube है, तो j cube का j square becomes minus 1, only single j remains, right? In the left hand side. Similarly, in the right hand side, j omega cube becomes here minus j omega cube R cube C cube. Second term में only j omega plus की जगह it becomes minus 6 omega square r square c square. It becomes an imaginary term, say real term, because j square is what? Minus 1. It is real term. Plus 5j omega rc plus 1. Now you can see I have to equate left hand side and right hand side. Left hand side, you have only imaginary term. In right hand side, we have the imaginary term, this is imaginary term, and this is real term. Agree? Left hand side only we have imaginary term. We can equate imaginary and real terms, right?
Yes, ma'am.
Right? Yeah. So we have imaginary term. I can equate imaginary term, that is RF upon R1 omega cube R cube C cube equals to imaginary term हमको अलग करना है. J term is there. And in the right hand side, J term is minus J omega cube. J को common ले लो, minus J R cube C cube. तो अंदर आ जाएगा minus 5 omega RC. Right? This is imaginary term. What is real term in the right hand side? Left. This is your equation number A. Suppose हमने imaginary term को compare किया. What is real term in the left hand side? Left hand side real term is 0. This is imaginary term. We are comparing imaginary term. Real term in the left hand side is 0. Right? No? Right. Left hand side imaginary real term is 0.
Yes,
But
ma'am.
in the right hand side it is 6 omega square R square C square. Right? In the right hand side it is 1 minus 6 omega square r square c square. And from this, can I write that what is my omega square? Omega square is 1 upon 6 r square c square. Right? Then what is omega? My omega is 1 by root 6 rc. Then what is 2 pi f? Omega is 2 pi f, 1 by root 6 rc. And then what is f? f is nothing but 1 by 2 pi root 6 rc. जो हमने स्टार्टिंग में बताया था. What is rc phase shift का oscillation का frequency? So it is 1 by 2 pi root 6 rc. We got this from real term only. No, there is no need of comparison of imaginary term. उससे हमको कुछ नहीं मिल रहा है. We are getting only this. Yes, what else we want is the gain. So now from here we can use A. So this is your B. Now from A, हमको omega square c square r square क्या मिल गया यहाँ से? You can say that omega square r square c square is equals to 1 by 6, right? यहाँ से मिला. Now from this B, substitute the value of B in A. To get the value of A, substitute the value of B. What is that? That omega square r square c square equals to 1 by 6. We have to substitute in the A. In A. Yeah. What is A? A में हमको क्या मिला है? Minus RF upon R1 omega cube R cube C cube equals to we are getting here is omega cube R cube C cube minus 5 omega CR. हमने J टर्म को हटाया ना. देखो क्या मिल रहा था यहाँ पे. J RF upon R1. तो माइनस नहीं है यहाँ पे. This is plus. ऊपर देखो J omega. This is A term. So when I'm having this, and this is plus.
मैम C cube आएगा ना
Right
right
now,
hand side में.
C cube. Yeah. So can I take omega CR common from right hand side? Omega CR common. So I'm getting minus omega C square R square plus 5. Right? And in the left hand side, I have RF upon R1 omega cube R cube C cube. From this, you can see that 1 omega CR get cancelled. So you have RF upon R1 omega square R square C square equals to minus omega square C square R. Right? Now, can we put the value of omega square R square C square as 1 by 6? हमको ऊपर मिला omega square R square is 1 by 6. So I'm putting here value of RF upon R1 as यहाँ पे ऐसे ही रखो बाकी 1 by 6 minus 1 by 6 plus 5. So what I'm getting here is RF upon R1 into 1 by 6. इसको simplify करो कितना आ रहा है? Minus 29. Right? 30 minus 1 is minus 29. Cancel 6 here. What is RF by R1? What is minus RF upon R1 is 29. And what is minus RF upon R1? That is my AV. So this is your AV. AV is what? 29. That I told that the design of. So AV I got is 29. So that means for RC phase shift oscillator, we have derived that, and the derivation is purely mathematics, or we can say your KCLs. Not mathematics, you have done KCLs also. So KCLs and mathematics. So it's not difficult. You have to just practice and just keep in mind that what we want is VB upon V0. So V1, V2 बीच में आ रहा है, that is unwanted. That you have to replace with whatever we are getting, and finally we have to get VB by V0 as beta, and we have to put the condition as AB beta equals to 1. So once you practice this derivation, then you'll understand it better. So what are the conditions we are getting? The condition for RC phase shift oscillator is F0 is 1 by 2 pi root 6, right? And second is AB.